Hmm. All right, so our topic today is, again, with U substitution. Mm-hmm.
How come, or how would you know when to solve for x? And I said sometimes you get like two x's, two variables, and you gotta solve for one to make it u.
So typically in that case, that's where you're going to have, you have another variable, but it's not the derivative of it. So remember how we had the square root of like 2x minus 1, and then you had an x on the outside?
Yeah.
So they both have the same power.
Yeah.
So one of them is not the derivative of the other one. So in that case, with our U substitution, we're able to modify both. So it's going to be when the degree is the same. Okay. All right, so let's go ahead and take a look at an example. And this example we should be comfortable with. So how about the integral of sine squared of 3x cosine of 3x dx? Okay, so yeah, what do we do? What's our u?
Sine 3x.
Okay, why are you choosing sine of 3x as your u? So because that's the inside function. Our outer function is something squared. Inside function is sine of 3x. So u equals sine of 3x. And how about du? So the derivative of sine of u would be cosine of u times u prime. So cosine of 3x times 3 dx. But we don't have a 3 cosine of 3x dx. We have a cosine of 3x dx. So here we're going to divide by 3. So du over 3 is equal to cosine of 3x dx. So we can replace the cosine of 3x dx with 1/3 du. So then that would be 1/3 the integral. So we already have the cosine of 3x dx as du. So there's our du. Now what about this part right here? Right here. So what goes here? U squared. Okay. So now we're set. All we have to do is take our integral, the integral of u squared. What's the integral of u squared?
1/3
So it's u to the 2 plus 1, u cubed, over 2 plus 1. And remember our plus c. So that's 1 over 9. Now we can back substitute. So u we initially set as sine of 3x. So that's sine cubed of 3x, and then plus c. So there's our solution there.
We tried to use the
Yeah. All right, so now let's take a look at evaluating these when you have limits. So what is the integral of from 0 to 1 of x times x squared plus 1 cubed dx? Okay, so Dennis, where do we go? Okay, so what's u?
X squared plus 1.
Yeah. All right, now what, Dennis?
Oh, I'm sorry, Dennis. Du equals
Not finished. 2x what?
dx.
Dx. Okay, now what?
Divide both sides by 2.
And why are you dividing both sides by 2?
Because you want to replace x in the integral with du.
Okay. So we have an x dx. So here, if we divide both sides by 2, now I can replace this x dx with du over 2, or 1/2 du. Okay, so this becomes 1/2 times the integral. So the x dx will be replaced with du, and u is equal x squared plus 1, so that's u cubed. Okay. Now, the limits that we have here are based on x, a function of x. We have now modified this for u. Okay, so let's see. I'm going to go ahead and put the limits here, but let's see what happens. All right, Dennis, you're not finished. What is the integral of u cubed?
1/4 u to the power 4 plus c.
Okay, well, we don't have to do the plus c because we have a definite integral here, right? All right, now, so it's 1/4 u to the power of 4. And we're going to evaluate this at 0 and 1, or are we? Well, if we go back through and we back substitute and make this again a function of x, then yes, we're going to use the 0 and the 1. So that's what we've been doing. We've been back substituting. So this would be 1/8 times x squared plus 1 to the 4th, and we're going to evaluate that at 0 and 1. Okay, so back to our fundamental theorem of calculus part 1. Do we want to keep the 1/8 on the outside, or do we want to go all the way through with it, distribute it? How do you guys want to proceed? Distribute it? So 1/8 and then times 1 squared plus 1 to the 4th minus 1/8 times 0 squared plus 1 to the 4th. One plus 1 here is 2. So here you're going to get 2 to the 4th. 0 plus 1 is 1. Here you're going to get 1 to the 4th. So we have 1/8 times 16, right? So 1/8 times 16 minus 1/8 times 1, because 1 to the 4th is 1. So our final answer would be 15/8. No?
Yeah, right.
Because isn't 2 minus 1/8 15/8? I don't know. That's what I think.
You don't need to reduce it. 16/8 minus 1/8.
Yeah, 16/8 minus 1/8 is 15/8. Right. Okay, so now I really need for you guys to focus on what we're going to take a look at next. All right, so this same problem, we were able to keep our limits 0 and 1 because once we completed our u substitution and our derivative, our integral, we back substituted. We put the original function back in, so it was still a function of x. But there is a way for us to evaluate this and not back substitute, keeping it in terms of u. Okay? So, take a look at this same problem, and I'm going to go through it a little faster just because we already have, we've already done the integration part to it. So here we had 0 to 1, x times x squared plus 1 cubed dx. U was x squared plus 1, du 2x dx, 1/2 du is equal x dx. So we had the integral 1/2 of u cubed du. Okay, but now I'm going to solve this without back substituting in the x. So I'm going to keep everything in terms of u. So that includes my limits as well. So u is equal x squared plus 1. So what is u when x is equal 0, our lower limit? So at x equals 0, then I get u is equal 0 squared plus 1, so u is 1. So my lower limit now becomes a 1. My upper limit here was 1, so when x is equal 1, u is equal 1 squared plus 1, so that's equal to 2. So my upper limit becomes 2. So now taking our antiderivative, we get 1/2 times 1/4 u to the 4th, but now I'm going to evaluate this at 2 and at 1. So I get 1/8 u to the 4th evaluated at 2 and 1. So that's 1/8 times 2 to the 4th minus 1/8 times 1 to the 4th. And you will notice you're going to get the exact same answer we got before. 16/8 minus 1/8 is 15/8. Okay, so you have the option of back substituting it and keeping your original limits, or changing your limits to reflect the change of variable u. So write your limits in terms of u. All right, so let's go ahead and officially write this down. So change a variable for definite integrals. All right, so the integral, well, actually, let's not start there. If the function u equals g of x has a continuous derivative, can't spell today, so it has a continuous derivative on the closed interval a to b, and f is continuous on the range of g, then the following is true. The integral from a to b of f of g of x times g prime of x dx is equal to the integral from g of a to g of b of f of u du. Okay. All right, so we're going to take a look at a problem you just asked about. How do you know when you go back and have to change both of them? Okay. All right, so oftentimes it's easier to leave it in terms of u. And there will be other times where you'll want to back substitute and put the original in. So you will kind of learn that with practice. But you're going to get the same answer regardless of if you back substitute, keep the original limits, or if you change it. But you want to do things efficiently. All right, so here is my challenge for you guys. What is the integral from 1 to 5 of x divided by the square root of 2x minus 1 dx? Okay. So you will notice in this particular problem that you don't really have one function as the derivative of another. Like if I let u equal 2x minus 1, then du is 2 dx. So here, this one's a little more difficult to solve. So what we're going to do in this case is we're going to let u equal the square root of 2x minus 1. Then, are you guys with me? All right, u squared, huh? No. So if u is equal to 2x minus 1, what's u squared? U is equal to square root of 2x minus 1. What's u squared? 2x minus 1. Okay. It's not plus or minus. U squared plus 1 is equal to 2x. So then that means that x is equal u squared plus 1 over 2. Now, we never did do du. So x is equal to u squared plus 1 over 2. Are we okay? All right. So we still need to replace dx, right? But this x I can replace with u squared plus 1 over 2. Everyone agree? Okay. This square root of 2x minus 1 we can replace with u. So right now, we need to rewrite that dx in terms of du. So this is what we have so far. We have the x as u squared plus 1 over 2 divided by u. Okay. And so we're going to modify that with in just a sec. But now, how do we determine what dx is? All right, so talk about that with your neighbors. Evaluate dx. Tell me what you come up with. You guys got it? I don't hear a conversation. What's dx? Yeah, because we need to rewrite dx in terms of du. Do what? I don't know. What did you guys get in the back over there? I don't hear any conversation. What's du? What's our derivative? You're going to get dx is equal to u du. All right, so here's what we have. We can replace the dx with u du. So u squared plus 1 over 2 divided by u is u squared plus 1 over 2u times u du. This u, that u, divide out to 1. We can bring the 1/2 outside. Okay, so now you have 1/2 the integral of u squared plus 1 du. Okay, what are our limits? Ben, we initially started with our limits as 1 to 5, but we're going to take the stance that we're not going to back substitute. We're going to keep everything in terms of u. So what are our new limits? It should be on your paper.
Alright, so since your old ones were 1 and 5,
Uh-huh.
when you plug them in,
Uh-huh.
you're going to get new values. So when x equals 1, you're going to get 1 squared plus 1 on 1/2.
Well, that's for u. Remember we said u, so u is the square root of 2x minus 1. So when x is 1,
That's 1.
so you're going to get 2 times 1 minus 1, so you're going to get 1. And then when x is 5,
9.
you're going to get the square root of 2 times 5 minus 1. 10 minus 1 is 9, so the square root of 9 is 3. So our new limits, when x is 1, it stays 1, but when x is 5, that's 3. Okay? So now we go through regularly, so we have 1/2, and the integral of u squared plus 1 is 1/3 u cubed plus u. And we're going to evaluate that at 3 and at 1 instead of 5 and 1. Now, if we wanted to back substitute, we very well could back substitute and keep it as 1 to 5. But I think in this case, it's easier if we just leave our limits in terms of u. So that is 1/2 times 1/3. 3 cubed is 27. Plus 3 minus 1/3, and then 1 cubed is 1, and then plus 1. (27) divided by 3 is 9. 9 plus 3 is 12, so you're going to get 1/2 of 12 minus, and then you have 1/3 plus 1, so 1 over 3 plus 3 over 3 is 4 over 3. Okay. That's our answer. I know. All right, so at this point, we can't take 6 years and a month on a test trying to figure out what the math is here without a calculator. So, what's going on? And distribute the 1/2. 6 minus, what's 1/2 of 4/3? 4/6, which is 2/3. So now you have 6 minus 2/3. What's my answer?
You got to get that common denominator.
Okay, what's our common denominator?
3.
Okay, so now we have 18 divided by 3, 18 over 3 minus 2 over 3, and our answer is 16 over 3. Okay. So we're not doing anything new. We're still using our u substitution. The only difference now is that we have limits. And you will see on your Unit 4 test that you will have some problems where you will not have a choice as to whether you can back substitute or not, because they're specifically going to be asking you about this.
How would you do this again?
All right, ladies and gentlemen, what can you tell me about even and odd functions?
Well, they're even and they're odd.
Yeah, but what exactly? What are the characteristics of an even function? How can you determine if a function is even?
If you do that negative thing and it comes out the same, then it's even.
I don't know what the negative thing
Neither
is.
do
Okay, so yes.
Graphically, isn't the even function the same as you expected
Across what?
the axis?
The which axis?
The one?
Yeah, so an even function has symmetry around the y-axis.
And the odd one, if you both get it.
So the odd ones, they have symmetry around the origin or a 180-degree rotation. So an example, our most common example is x squared. So here, x squared, it's an even function. It has symmetry over the y-axis. Whereas the function x cubed, it has symmetry about the origin. It's an odd function. So what Ben was saying earlier about the negative xy thingy, so if you use the composition, so an even function, f of negative x equals f of x. So if you take a function and you do the composition of f of negative x, replace all of the x's with negative, and you end up with the exact same function you started with, that's an even function. So if we say that f of x is equal x squared, then f of negative x is equal negative of x squared, which is x squared. So f of x and f of negative x are the same function. Then you have an even function. If your function is odd, then f of negative x is actually equal negative f of x. So that's negative 1 times f of x. So this function here, f of x is equal to, let's say we have 2x cubed plus x. If we evaluate f of negative x, then we're going to get 2 times negative x cubed plus negative x. So negative x cubed, negative x times negative x times negative x is negative x cubed. So you're going to get negative 2x cubed and then minus x. So what we notice here is that your answer with the composition is the same thing as negative 1 times f of x. So this is an odd function. So basically what you're looking for in an odd function is if you do the composition of negative x, if the signs of each of your term changes, that's the same thing as multiplying through by negative 1, then you're going to get an odd function. So it's what? Even?
Neither.
It's neither. If
When it's
you
not all the time.
if you have 10 terms and one of them doesn't change, then it's neither. Okay, so why is this significant in calculus? All right, so and you can save yourself some time in the integration of even and odd functions. Odd, can't spell. Okay, so if f is even, then the integral from negative a to a of f of x dx is equal to 2 times the integral from 0 to a of f of x dx. So in this case, because they have symmetry over the y-axis, if I'm going from negative 3 to 3, really all I need to do is go from 0 to 3 and multiply it by 2. Because the areas on both sides are going to be the same. So that's with your odd function. So example, if you had something like this, and this goes from negative a to a, and we wanted the area under the curve here, why don't I just take the integral from 0 to a and multiply by 2, because both of these areas are going to be the same. Now, in the long run, it really doesn't matter. I could go from negative a to a. What would a benefit be of having 0 as one of your limits? Okay, so you may end up with less math. Because if 0 is one of my limits and my antiderivative only has x's in it, when I plug in 0, then it's going to 0 out. Definitely less opportunity for error. And when we get into the later units, you are going to be utilizing that a lot. Okay, odd. If f is odd, then the integral from negative a to a of f of x dx is equal 0. Remarkable, huh? Okay, give you an example. By the way, with your trig functions, the 6 basic trig functions we know, which ones are even? Which ones are odd?
I think there's only 2 even, don't
Yeah, there are only 2 even. Which 2 trig functions are even?
Is it tangent? No? I remember 2 are even.
Cosine is even, because cosine in the first and the fourth quadrant is positive. So cosine of 30 degrees and cosine of negative 30 degrees are the same. Right? Cosine of 30 degrees is what? What is it? Square root of 3 over 2. Cosine of negative 30 degrees is square root of 3 over 2. So who is cosine married to? So cosine goes with secant. So cosine and secant are even. So even cosine and secant, and the other 4 are odd. So your odd functions are sine, cosecant, tangent, and cotangent. Okay, so sine, cosecant, tangent, cotangent. Those are your odd functions. So here, so you guys, when I first gave you this a couple of years ago, why is it 0? Well, take a look here. Remember, it has origin symmetry. So let's go from the graph of sine from negative pi to pi. So the integral from negative pi to pi of sine of x dx is going to be 0. Because you have this part of the graph that's above the x-axis. That's positive. This part of the graph is below the x-axis. That's negative. These two cancel each other out. Okay. Let's say I gave you this problem. The integral from negative 2 to k of x cubed plus x dx. So my question to you is, what value of k will guarantee that this integral is 0? So what value of k makes this true? Okay. Any suggestions? 2? Why? Okay. Okay, the only way that's true is if this is an odd function. If this is an odd function, then the integral from negative a to a is 0. Is this an odd function? So since x cubed plus x is an odd function, then 2 would be a solution. If this were even, then that would not be the case. But because this is an odd function, the integral from negative 2 to 2 is going to be 0. But that's not the only answer. You guys are missing one very obvious one. -2.
Oh, yeah.
The integral from -2 to -2 of anything is going to be 0. So in this case, you have two solutions. Not only is it 2 and -2, not only is it -2, but it's also -2. But on the other hand, if I gave you this one, then what would your solution be here? What value of k makes this a true statement?
Just -2.
Only -2. Because this is an even function.
Every value is -2.
So this is an even function. It's reflexive over the x-axis. So the only value that's going to make this true is k equals -2.